Now, so we're trying to do 7.1, the law of sine. And I do have the law of sine right in front of you, so that's all you need to know. Right. So if you're thinking we're gonna need that for so we need to solve for triangles. So by solving triangles, I mean we need to find missing sides and angles. So we did that before in chapter 5, right? But we were able to solve only right triangles with you know, the right angle tricks, right, sine and cosine stuff, the SOHCAHTOA, right? But now there won't be any right angle in the triangle anymore, right? So it's called the oblique triangles. Yeah. That's a reality. So you won't be able to use the SOHCAHTOA right off the bat, but you can still use it, but in the right way, which is the law of sines. Now, please make sure that you're okay with the notation. So those lowercase letters, A, B, C, are the sides of a triangle, and the capital letters are the corresponding vertices. Right. So since let's say letter A, right, and a lowercase a, right, they're a corresponding side and angle pair. You just have, you know, a whole bunch of ratios, right? And we do see that there's some equations here, right? But let me ask you guys, how many equations do you see over here? Some say one because it's like a whole thing, right? One line. Or people just by counting the equal sign, they say 2. Or Maya, you said 3, right? You're right. So can you tell us how you realize there are 3 equations? Right. So it turns out that all 3 ratios are the same. And people are lazy, right? They just put everything in one line. So now you need to realize that the way you're going to get yourself an equation to play with is to take 2 ratios, set them equal, right? So you can take the first and the second one, set them equal. That's one equation. Or the first and the third, right? Or the second and third, right? That's why there's only 3 possible ways of getting it. Now, if you're looking at one of those equations, right? So let's say the first one, right? A over sine A equals B over sine B. How many variables are there? We have 2 lowercase letters, which are 2 sides, right? 2 uppercase letters, 2 angles. So 2 sides, 2 angles, right? That means that if you want to use one of those equations, you need to know at least 2 sides plus an angle to find out the other one, right? Or 2 angles plus a side to know the remaining side. So that's that easy. Now, when it comes to solving angles and sides by using that equation, all we have to do is to do cross multiplication, and you're almost there, right? That means that there shouldn't be any algebra that ever bothers you in this topic, okay? The only thing that you're not so used to is that you don't get to see right triangles anymore, right? Now, well, let's just jump right into an example so you see how straightforward it is, okay? So we have a triangle here. They label the angles and the sides, right? So we know 2 angles in a side, not to mention, you see that C and little c, they are a pair of corresponding side and angle, which is always good because you see that those ratios are all about angle and the corresponding sides. So in the test, if I were you, I will always write down the law of sine at least once, put it on top, right, of the test paper or maybe the spreadsheet. So I can have this right in front of you, so you can plan, right, what you know and what you can do to solve for the missing stuff. So let's say we know the angle A. We know the C, right? The angle C. We know the little c. So let's say if we want to find out what little a is, how would I do that? Or which two ratios should I pick to assemble the equation? A over A and a C over C, right? That's the first and the third ratio. Well, let's do that. So we're plugging in the numbers. A over sine 64 degrees. And in this chapter, you're most likely dealing with degrees. Equals 14 over sine 82 degree. And do multiple. Yeah, go ahead, Juwan. Yes. So I'm glad you say that. So Juwan mentioned that. Why don't you just get that remaining angle figured out? That's the easiest thing to do, right? So yeah. So if you want, go ahead and figure it out real quick. So it'll be 180 because they all add up to be 180, right? So 180 minus 64 minus 82, right? So my student in the first period told me that's 34 degree, right? So that's the capital B, so we know that as well, right? One less thing to worry about. Good. Now back to this equation. So I said just do cross multiplication, right? A times sine 82 degree equals 14 times sine 64 degree, right? So how would I get A? By both sides by sine of 82 degrees, right? So go ahead and we do 14 times sine 64 degree, right? Over sine 82 degree. So can you guys figure it out what that is? Make sure that your calculator is in the degree mode. All right, let me know once you get it. Use the calculator. How much is it?
I have a question.
Go ahead.
If like we get an FRQ of this, will we need to write like all of that down? Or can we just say what?
It depends on what you skip, or again, let me put it this way. If you do get all the things I want, for example, the missing size and angle all correctly, I feel more likely that I'll give you the full credits. If there's some mistakes, then I find it hard to award you any partial credits because there's no work, or there's not the work that I could give you points for, right? So you decide, right? But I said that you're better off to show me work, right? Or as much work as you can. Anyway, so how much is A? 12.7. Yeah, you got it. So in centimeter, right? So now let's say we have all three angles, right? We have two sides already. So we have only one missing, right? Which is the letter B. Do you guys know how to figure out what the little b is? We know A already, right? So it's the only thing that's missing, right? So would you say that you do the same thing as you did to solve for A, that you're going to do that again, right? To solve for B, right? Set up the ratio, right? Cross multiplication, right? Figure out a B. That's all. All right. And it turns out the first 5 questions in the third quiz will be pretty much like that. So the quiz I published and we do on the 17th, which means that I don't think that you guys are going to be starting the homework tonight because, we're not done yet, right? But everyone should be seriously trying the first 5 problems in the quiz, right? Get them done. I don't think it's going to take you that long, right? Finish them, have your work saved up, right, in your notebook. So you probably don't have to look back until maybe sometime next week before you come back for the quiz, right? There are, by the way, there are only 21 questions that I picked for the quiz for you to review before you come to me. So just do 5 problems every day, right? So you only need 4 days to get them done, right? Then you just have to review, memorize them, right? And come back and get a quiz done. All right. Okay, so now, you can see the second checkpoint or a second example in a textbook that's almost trivial because there's still two angles, right? That means you can easily find a third one. They basically, instead of providing the A, you choose a little B, right? You're gonna solve for the remaining sides and angles, right? So I'm gonna skip that, right? It's just trivial. So let's work on something, more meaningful than that, which will be the so-called ambiguous case. Why?
Yeah, I just hate the triangles.
In general. Well, turns out that triangle is one of the most stable structure in nature. Yeah. So they make bridges, all the kind of things with triangles.
Why is it ambiguous, right? Like, it doesn't have to do anything by it.
That's why we need to look into so I mean, what does it mean, right? The situation is ambiguous. So it turns out in some problems, given the size and angles, there might not be a triangle at all. So the triangle does not even exist, right? So you cannot solve for anything. Or there could be a triangle, or could be two triangles, right? Both of them will go work, with what they're given. So it seems like that you need to know ahead of time if there will be no solution, one solution, or even two solutions, right? Like predicting them given the size and angles. Not to mention that, have you guys seen the combination of SSA before, right? In maybe congruence, right? So this is the combination that you cannot prove the congruence, right? But let me show you in the next problem that you don't really need to pretend that you actually know what the ambiguous case is, because trust me that math will work out itself. So you will just do what you have to do, like you saw in the previous problem, and you will see that if there's no triangle or one or two, you will know it. Right? There's no need to know ahead of time. Or at least this is what I think. Okay. Now let's take a look at this problem. They told us the angles on the side, right? So they didn't even draw for us, right? For a reason, right? But you know what? Let's pretend that we didn't realize, right? There's no solution. Let's just go ahead and do it. So again, I'm gonna write the law of sine. Once again, right? Just have it right in front of me. So I can plan the math before I actually do them. So what do we know? We know capital A. We know little a, right? And little b. So now, what would you solve for right off the bat, knowing little a, b, and a capital A? Some say sine of b, right? So you're trying to get the capital B, right? The angle B. Yes, let's just take that first equation, right? And let's do cross multiplication, or we'll plug in the numbers. So A is 10. 10 times sine of B equals little b is 20. 20 times sine of A, which is 50 degree. Right? You're going to get the sine B isolated, which is 20 times sine of 50 degree over 10, right? So can you guys tell me how much sine B is equal to just by plugging this into the calculator? Make sure you're in degree mode. What do you guys get? Sine B is 1.5. Right? Do you guys all get that? Okay, so now at this point, how would you get the angle B? If sine of this angle is 1.5 using the calculator. No, 30 is 1/2. Sine 30 is 1/2.
Oh, you
X.
place the inverse sine function to get the angle.
Yes, it's been a while, right? So, and that was the reason why we learned the inverse, right? So yes, go ahead and put in sine inverse of 1.5 to get you the angle B and tell me what you get. Type it in. Sine inverse 1.5. Maya, what do you get? What does it say? Error. Okay. That means it does not exist. All right. So the calculator complains. And so, well, let's see if you guys do remember what was wrong with like that. Why do you think the calculator complains? When you're putting 1.5 into sine inverse.
Because sine cannot be over 1 and cannot be below -1.
Okay, that was right the inverse function, right? We we even had a code on it, right? So yeah, 1.5 is outside the range of sine, or it's outside the restricted domain of sine inverse. But either way, see that sine cannot be greater than 1. Therefore, the angle B does not even exist, right? That means the triangle does not even exist, right? So now why would you have to predict in the first place there's no triangle? Because if you had a problem like this in the test, you're gonna have to work this out anyway, right? There's no point for you to tell ahead of time there's no solution. So you just go do it, and your calculator is gonna tell you, right, when you get to that point. That also means that don't freak out if you had a problem like that in the test and somehow you realize there's no solution, because it might be, designed to be like that. Okay. Now, since you see it mathematically, even from the range and domain, that there's something wrong with the sine B. So let's also visualize what's going on with this triangle, like why you couldn't have such a triangle. So we have the angle A to be like say 50 degree, right? So the B, oops, is 20 units. So you might say, how do I know that has to be the B? Well, it doesn't have to be, but that seems to be a reasonable way to put it, because at least I know that this cannot be A, because little a is the opposite of angle A, right? And these two are two adjacent sides, so they're going to be either B or C. And just pick maybe the one on top and call it the B. So the little a is only 10 units, right? So if this is how long 20 units is, right? And 10 units will be something like this, half the length, right? But that is the opposite side of the 50 degree, right? And this is only 10. Do you see what's going on? That side A is not long enough to even reach the base of the triangle. It's too short. It's either too short or the angle is too big. You see that? You have such a large span. If I were to make angle A to be 20 degrees, that work, right? No, at least that I can reach it. So it's that obvious. But like I said, there's no need that you have to know ahead of time if it won't make a triangle because you couldn't close it. Because you will have to work it out to show me that there's no solution. And when you do it, you will know somewhere along the way, there's no way you can miss it. Okay. But there will be some triangles that could be ambiguous in a way that just by giving you the angles and the sides like that, you might be able to figure out two triangles and both of them work. Right. So unfortunately, if that's the case, well, you better have more points for that, because it's like doubling the work, right? So let's take a look to see, how bad it could be. And it turns out that it's still pretty straightforward. right? If so far, you've been getting used to the kind of routine things you do about solving oblique triangles. Anyway, now I don't think that you really need to draw a triangle, right? Or I'll say that it's not even worth the time, right? So, but what definitely worth the time for you to put down will be, again, the law of sines. Okay, so we know capital A, which is 35 degree, right? We know little a, we know little b, right? So, I mean, guess what? I feel like that I'll just solve for letter B, right? The capital B, right? Since it's ready. So from the first equation, right? So you know what? Let me just let you know what I did. So A times sine B, right? Cross multiplication. So 12 times sine B is, letter B is 16 times sine of A, 35 degree, right? So I'm going to solve for sine B, which is 16 times sine 35 over 12. Again, can you guys do me a favor? Tell me what sine B is equal to. What do you guys get? Sine B is 0.76. Yeah, that does agree with you know, the book, right? So now, do you see that this is not a problem anymore, right? Sine B is indeed less than 1. That means you can invert it to get what the angle is supposed to be, right? So go ahead and find me what sine inverse of 0.76 is equal to.
8.6 degrees.
Okay, so 49. So maybe let's just
49.9.
49.9. So let's go with 50 degrees. So it'll be a little bit easier to calculate things in the future, right? Thank you. So it's about 50 degree, right? Okay, so now you guys literally had the test yesterday. Let's see if you still remember. Because now, if the test didn't work out because, you know, the way it was given, I'm not mad. All right. But you literally had the test and you were reviewing, you know, we've been doing this for so many times and you don't remember, then I do get upset. Right. So you tell me, is that the only angle that'll work out?
No.
How do you find the other angle? Coterminal. Now in this case, keep in mind that those angles better be less than 180 degrees, right? Those are all the angles in the triangle, right? Yeah, will be the best way that we've been trying for so many days to find out the second angle. Once we know that either sine of something or cosine something equal to a number, right? I had a chart so that you have to calculate, right? So just read off. It would be 30, 45, 60. Let's find out the second angle. It's just that in this case, you don't get to look up the chart. You get that angle, the first easy one from the calculator. How do you find the second angle? What do we do? Say it again. Subtract that from 180. You guys just memorize that? Good. And also I heard someone saying, what's the name of the skills that we're trying to do? We draw the unit circle, right? Wow. You know what? To me, the unit circle is one of the best tools out there for trig. Anyway, I couldn't even draw the circle now. All right, so sine is the vertical coordinate, right? So now if I'm looking at an angle that's 50 degree, right? That's associated with a P. And I know that to have another point Q with the same vertical coordinate, so that has to be on the other side, right? Making the same angle with the horizontal line, and therefore one of the angles is 50, right? The other is going to be 180 minus 50. So B could be 50 or 130, right? Okay, so but we're solving for a real triangle. That means, is it possible for the angle B to be that big? Well, what I know, if it will be too big, would you? Okay, you either add it to 35 to see if there will be any room for the remaining angle, right? Or you might say, well, how much will be the third angle, right? So it'll be 180 minus 35, right? That's angle A for sure, right? If it's were 50 degree for B, you subtract 50, right? So you see there's some room, right? So this is 85. So I'll say 95 degree, right? That's fine. It's, not a nice angle, but it's an angle, right? Or C could be 180 minus 35 minus 130, right? If the B is such a big angle. Now that leaves us, a small room, right, for C, but still, it's what is that? 15, thank you. 15 degree, right? Now, would you keep both possibilities? Yes, because there's no reason you should reject them, right? So now, let's say you have the first case, right? So case number 1. So A is 35, B is 50, right? C is 95, right? Now what do we have? A and a B, right? So little a is 12, little b is 16, right? And we're missing little c, right? I know that looks pretty much the same as the capital C. Let's make this a bit bigger. Capital C, right? So I'm sure that you know how to figure out the little c, right? It's just everything's given except for that little, side out there. Now, the second case that you have A to be 35, that's a 5. B is 130. Now C is 15, or you still have A be 12. You see that it's just repetitive. And you can find out what the C is, right? So now for a problem like that in a test, I think that, it worth maybe 7, 8 points. Okay, just for the second case, right? But if I zoom out. Now I didn't complete everything. I'm sure that you know what to do, right? To get the math done. But I want to see the general picture. Okay. So we saw sometimes there won't be a triangle and you'll be alerted by the calculator somewhere along the way, right? Nothing to worry about. But this might be kind of bad if you didn't realize when you could invert the sign to get an angle, right? Don't forget that is another possibility. Okay. But it doesn't mean that you're gonna keep both possibilities. You only keep them if you're able to solve for the third angle.